Okay, well, what I'm going to try to do here is give you a little, real quick introduction to using Hypermesh for making these one-dimensional models that you'll be doing for this project. Um, so since you might have like 100 or so elements, it's kind of cumbersome to type in all the things by hand, obviously. So this is where a graphical preprocessor comes in handy. Now, the nice thing about Hypermesh is it's program neutral. Excuse me. So in other words, it works for pre-processing things for Nastran or ANSYS or Abacus or LS-DYNA or a variety of other programs. And if you get used to dealing with the input file deck, the cards, Hypermesh supports that sort of approach quite well. And so I think, in fact, to do, there might be some GUI preprocessors out there that are a little more, quote unquote, user friendly. But I think Hypermesh is actually the most powerful if you're going to try to do any sort of serious analysis. I think it's really the way to go. All right, so I'm loading it up here. But let me just pull back up. But basically, so what I'm going to do is I'm going to model a real simple bridge. Obviously, this is a little trivial. And it's 3D, so here's the front view, here's the top view. It's basically two parallel triangular truss types of bridges, okay? And we'll put a load on it, we'll set up a load case and all that sort of stuff. Now, when you make the file in Hypermesh, one of the good things you probably might want to do is sort of follow this approach. The first thing, well, as I mentioned, you can use this to support a lot of different finite element codes. We're going to use Nastran, so pick Nastran. Okay, this is what's called the user profile. Here you can see you can pick a variety of softwares. Now, when you pick one of these, it kind of changes a little bit the way Hypermesh works, so that it supports the actual cards for that program. So we're going to do Nastran. Actually, OptiStruct is very similar to Nastran. Okay, so we hit OK. And actually, if you want to use OptiStruct and solve it directly in here, that's probably OK for this problem as well. All right. So as I mentioned before, I think a reasonable way to kind of tackle these problems is to follow the following order. Now, if we think about Nastran in sort of a hierarchy, you have your material cards. Those are referenced by your property cards, and those are then referenced by your elements, whatever. We'll use CBAR in this particular problem. Okay? And in a similar manner, you have, for boundary conditions, you have SPCs and maybe forces. And those are referenced by the subcase. Okay, that's sort of the organization of these things. So in Hypermesh, you can go back and edit things, but I think things work relatively smoothly if you move down in this manner. So what I mean by that is, first define the materials, then define the properties, the PBAR cards or PBAR-L cards, then define the actual elements, and likewise, then we go to do boundary conditions, define the single point constraints and the forces, and then define the subcase, which actually in Hypermesh they actually call this a load case. But it'll translate into the Nastran subcase file. All right? Okay. Okay, so that's the approach I'm going to do. And now Hypermesh has a couple of things that are a little bit different. It has this concept of what are called collectors. And those are sort of like levels, if you want to think of it in a CAD type of terminology, but they can hold objects. So they can hold elements, they can hold properties, they can hold boundary conditions. All right. So here's a new model. We set the preference to be Nastran. you've got things down here, and then they're actually usually reflected by pull-down menus up here. This is sort of the older way of doing it. This is the newer way of doing it. You can use these things to dynamically rotate and pan around. Okay? And the interesting thing is this menu bar on the left, I'll be referring to this a lot. This is the, under model, if you click the model tab, this will be the tree that sort of organizes our finite element model. Okay. So let's go back and let's define material cards. All right? So to create most of these things, you can right-click directly on this menu tree, and we can create a material. Right. Now, when you do that, you get a pop-up like this. All right. Now you can give it a name. This is really just used by Hypermesh. We can call it birch. I actually forget the birch properties that I gave you, but let's just leave it like that. And the important thing is the card image. So you can see now we're talking about Nastran. See, it supports Mat 1, Mat 10, Mat 2. We're going to use Mat 1. All right. So we're going to define a Mat 1. We're going to call it birch. And then if you click this one, this allows you to edit the card directly. So once I do create, you can see you actually get this little spreadsheet looking thing that pops up. This is exactly the fields for the Nastran model, right? For the Mat 1 card. So here's the ID. It automatically sets that to be 1. It keeps track of all those for you. You can put in Young's modulus. I forget what it is for birch, but let's just say it's, I don't know, 2 to the 6th. I think this is probably pretty high. Like 2 megapascal, mega psi, and then also put in Poisson's ratio of like 0.3. I'm not sure what it is. Okay? All right. So there you go. That's the material card. So we've done the first part. We've defined the materials. Now let's define the properties. Now in this case, we're going to use really one property. We'll just use this one cross section. This will be our, and we'll use a P bar L to define that. Okay, but we'll use that rectangular cross section. Okay, since all the popsicle sticks have the same dimension, all right? Okay. So again, I'm going to right-click, and you can see now that I created a material, it's listed here. There's the birch material. If you have multiple materials, they'll be listed there. Let's create now a property card. I'm going to call it popsicle cross section. We'll assign the material to be the birch. That'll just peg the material ID in the card. You'll see that. And the card image in this case, again, is we're going to use a P bar L. Again, we'll edit it, create it, and here you go. Here are those cards, all right? All right. This is the actual cards for the P bar L. Now, I always forget what are the dimensions, so you can actually go into Hypermesh Help. And if you look under Help for OptiStruct, it's actually the same as Nastran. OptiStruct is very similar to Nastran. You can see the actually P bar L in there. Let's see if it loads up. Sometimes it doesn't always load up on these My Desktop things. Yes, oh, there it goes. All right, so we can search, P bar L, see what pops up, get help on that card. And here it gives you the card, the fields in the card. And we want to use the rectangular. Where's the rectangle? Yeah, okay. So this is a bar, and dimension 1 is the smaller dimension, and the height is dimension 2. Okay. I mean, you can flip it either way, but we'll assume that the taller dimension is in the y plane. So when we do our orientation vector, okay. So dimension 1 is going to be this 1/8, that's going to be dimension 1, and this is going to be dimension 2. Whoops. And so that means that is plane 1. So my orientation vector for those things have to be in that direction. Okay. Okay, let's go back to Nastran. I mean the Hypermesh stuff. Where is it? Back to here. We close this down. I don't really need that anymore. And here we go. So we're going to choose bar. There it is. Dimension 1 is the 1/8. 1 divided by 8. You can actually put it in that way and it'll... Oh, you can't. Okay. You used to be able to do that. I guess they've changed that. Okay, well, it's 0.125. That's 1/8. Ah. 0.125. Okay, that's that dimension. And this dimension is the 3/8, which is 0.375. Okay? So there you go. It's now defined. I don't know why it does this group thing. It sets that for you as part of it. Hypermesh keeps track of that by yourself. Okay? Return. Okay, so now that's created. You can see that property has been created. And if you had multiple cross sections, you could do those. Like if you wanted to do a built-up section, you could define the geometry of that section and put it in there. All right. All right. Now where do we stand next? Now we've defined all our materials and all our properties. Now let's actually define the elements. So the elements are going to sit in a collector. So you can have multiple collectors, but let's just make one collector for now. So I'm going to make a collector. You can see there's load collectors and component collectors. So we're going to use component. And I'm going to call this front bridge, whatever. And actually, you can put properties and materials, but with the 1D elements, you really don't need to do that. So you just create that, all right? And now you can see we've got the component, we've got a title. You can actually edit this, card edit. Oh, that one didn't support that one. Okay, well, sometimes you can edit those. But you can see, like, for the popsicle cross-section, if you right-click on it, you can do card edit, and the actual card pops up, and you can edit those properties, okay? Just like you would. So it's when people first start doing this, they think it's very bizarre, because if they don't understand how the Nastran input file works. But if you're comfortable with those types of input files, then you can see it actually supports it quite nicely. All right. I don't want to go too long in this video. It's only been 5 minutes. All right. So now, for this type of model, what's probably not a bad way to start making geometries is I'm just going to I'm going to type in some points of these sort of vertice locations, you know? And the way I do this, although I think it's all supported up here as well, I tend to like these lower menus. This is what I've been always using. I've been using this program for like 10 years or something. And, this is nice. Geometry allows you to create things like points, lines, curves, surfaces, even solids. You use this 1D menu to define one-dimensional elements like bars and rods and rigid elements. You use this 2D this 2D subpanel to mesh things with two-dimensional elements like linear strain triangles or constant strain triangles or four-node quads. Again, for three-dimensional mesh generation, you have this panel. Analysis supports things like where we define our boundary conditions, both SPCs, which go through constraints, and our forces, which go through forces, and then also defining the subcases, or the load steps. And then tools allows you to delete things, move things, scale things, reorganize them, count the numbers, calculate mass of your model, and finally you can solve and post-process as well. All right, so we have to make some points. So the way I'm going to do it, again, if you look back at my mesh here, I'm going to turn this off in a second, but I'm just going to define these 1, 2, 3, 4, 5 points, all right? And that's pretty easy. We can do it just by typing in the coordinates. So we'll put one at 0, 0, 0. Then the second one I'll put at 20 inches in the X. And here you see this one lets you like see the whole thing. The next one will be at 40. I can create that. Now you see I've got those two. That's the bottom edge. Now we're going to move up to 15 in height. And the first one is going to be at 10. That's sort of the top mid node. There it is. And then the next one is going to be at 15. No, 25, excuse me. 25. Great. No? Where is it? There it is. Okay. Did I do that right? That looks wrong. Wait, 35. It should be 35. Forget that one. Let's make this one. That's the right one. Create. Wait. I'm losing it. It's 10 plus 20. It should be 30. Sorry. I'll get it right. It doesn't really matter. There it is. I'm going to use that one. We can forget these. Okay? All right. Actually, if you want to delete them, you can go to temp nodes and you can select these guys. Select the next one. And then you can just clear those and they go away. All right? All right. Well, now I can at least, I can kind of use this to rotate. Which one to rotate? Well, okay, here we go. You can actually use Control and the left mouse. Oops. Let's do it again. I do it so subconsciously. If you hit down Control and move the left mouse button, it lets you rotate. If you hit Control and then the middle mouse button, you can zoom in on things by doing that. You can actually sketch the zoom window. And if you do the right mouse button and Control, it lets you pan. All right? So you can do that dynamic stuff, which is kind of nice. All right, so now we're going to draw the elements. All right, so now we're going to go to 1D because we're actually going to generate the elements. So the way it kind of works is in Hypermesh they have these names. These don't always correspond one-to-one with the Nastran element. So a bar might not always be a bar element. A rigid element might not always correspond to an R-bar element. Okay. The way you map these onto the specific Nastran elements is through element types. So if I click on element types, you can see that by default, a bar element will want to create a beam element. Well, I don't want to do that. I want to use CBAR elements. So I'm going to change that to be bar elements. See? So that works quite nice, actually. And you can do the same for the other ones. So you can change a rod element to actually be a C-rod element if you're so inclined, okay? All right. Okay. So there you go. So now let's create some bar elements. All right. Now if you look at this menu, this allows you to define them. You pick the 2 grid points. You can pick the element type. These are going to be C-bar. You need to define the property card. So if you click on that, you can see it allows me to choose one of the property cards I defined. I only have one, so that's it. Here are the pin release degrees of freedom, right? You can do the offsets at A and the offsets at B. We won't use those. And you can also, well, here's where you define the orientation vector. Now in this case, all our elements are going to be in this plane. So if I pick an up arrow, if I pick the y-axis as my orientation vector, that'll definitely get those. It should also get all the other ones in this plane. So I'm going to take this orientation vector and make it to be the y-axis, okay? So now I should be good to go. So now I can just pick nodes. So the first element, I'm going to go from here to here. There it is. Second element will go from here to here. Third element will go from here to here. From here to here. And all that sort of good stuff, right? So, whoops. First element, second element. There you go. So I like that, all right? Whoops. Come back here. So that's kind of the way it looks, right? Probably it's a little too tall for a normal type of bridge system, but that's what I got. All right, so you can actually go back and look at these, and like, for example, if you pick this little window, this is kind of nice. This allows you to edit cards. You can actually, like, edit the actual element. You can look at the element itself. Like, you can pick element and then pick this element, for example, and then say edit. And it'll show you, right, this is the C-bar card for that, okay? And it shows you the orientation vector, the grid points it connects, the element ID, the property ID, all that good stuff. All right. Okay. Now we got to make this back frame, right? So we kind of have all these guys. Whoops! I keep zooming in when I need to rotate. All right. So this is the front plane. We need to make the back plane, which is going to be the direct copy of this, but just move back in Z. So you can do stuff like in Tools. Remember I said that allows you to do copying. This is a little weird, and I'll do this quickly. You can stop and go over this a little more slowly if you want, but you just have this one. There's lots of tutorials in Hypermesh to help you do this stuff. So we're going to do translation, and we're going to translate elements. So I'm going to pick all the elements, and I'm going to translate it in the Z direction by a magnitude of 5 inches, because that's what I said it would be. And now I want to copy them, not move them. So if I click again under elements, I can hit duplicate and duplicate them to the original component. All right, doesn't really matter in this case. And then we can translate plus, and there you go. Those are our new elements. So just again, to see that again, if you do translate, you can translate a variety of things. The type of thing you want to translate, you can change by pulling down this arrow. You can translate nodes, components, lines, lots of other things. And to actually select them, you click on the word element, and then you can do by window, you can pick all of them, you can actually just pick them with the mouse, you can pick them by collector. There's lots of ways you can do that, okay? So anyway, there we go. There's our bridge so far. Now the next thing I need to do is I just need to connect up the back and front. So we go back to 1D elements. We're going to make some